Okay, so I've got 4 questions here, I think. Um, right, so we're given some information there about the diagram. It says it is a circle of radius length 1, which is in the picture. SOW. So SOW is this angle here. Yeah, and it says that angle's 90. That's not in the picture. SW is a tangent. Yes, it is, which is a line that touches the circle at one point only. OC intersects SW at W. Oh yeah, so OC is the line here, and it intersects SW at W. That all makes sense. UCO. UCO. So that's there is 90. So that is in the picture. Because there's a square there. UOW. Yeah, it's also there. Go a bit thicker with these. UOW is this one here. And they're saying that that's theta, which it is. And then SU is perpendicular to OU. So SU is there, OU is there, and they're saying they're perpendicular, which you can see by the 90. Okay, find SOU in terms of theta. So SOU in terms of theta, SOU is this bit here. Yeah? So in terms of theta, it's going to be 90 minus theta. Whole angle is 90 minus the theta at the bottom, 90 minus theta. Hence explain why OSU is theta. So OSU is this one up here. Yeah. Why is that theta? Well, the 3 angles add up to 180. So 90 plus 90 minus theta plus the angle at the top in S is equal to 180. So 180 minus theta plus S equals 180. If I minus the 180 to bring it across, then I get minus theta plus S equals 0. And then if I plus the theta and plus the theta, I get S equals theta. So explain why OSU is equal to theta. There you go. I'm just going to put C back up here a bit. My iPad is definitely going to die, so I'm going to keep going until it does, and then I'll have to record this in the second half. Anyway, so UC in terms of sine theta. So UC in terms of sine theta. Okay, so if we look at this triangle here, yeah, there's the marked angle, so that makes this the opposite. There's the right angle, which means this one here is the hypotenuse. Yeah. And then that makes the bottom one here the adjacent. And for this question, they want us to do sine theta. So we did SOHCAHTOA, so sine is the so part. So the sine of theta is opposite over hypotenuse. So the sine of theta is UC, which is the opposite, over 1. So sine theta equals UC. Because anything over 1 makes no difference. And then the last one there, part D, is this exact same thing except with cos. oh sorry, not that one, this one. So SOHCAHTOA, that's the cos parts. So the cos, sorry, I'm using theta because the question uses theta. We don't really use theta, do we? We normally say A. So the cos of A is adjacent over hypotenuse. So the cos of A is, the adjacent is OC, you can see from the picture, and the hypotenuse again is 1. So the cos of A is OC. Okay, and then the last part says that sine theta squared is written as sine squared theta and cos theta squared is written as cos squared theta. Use your answers from C and D to evaluate the following: sine squared theta plus cos squared theta. Okay, so sine, they were using theta anyway. Sine squared A plus cos squared A is going to be UC squared plus OC squared. To evaluate sine squared theta plus cos squared theta. So UC squared plus OC squared. Do we know the length of any of them? No. We know that that's 1. We know that that's that. We don't know what theta is though. But that's gone anyway, so it doesn't really matter. It's another radius. I mean, the only thing I think they're getting at here, this is a weird question, but the only thing I think they're getting at here is Pythagoras. So Pythagoras is c squared equals a squared plus b squared. Yeah? So c squared is the hypotenuse, and you can see the hypotenuse just there in the left-hand side is 1. A squared, it can be any, so let's call it AUC. And b can be OC. Yeah? And then 1 squared is 1. So, according to Pythagoras, UC squared plus OC squared equals 1. So then over here, UC squared plus OC squared must equal 1. And that is evaluated, as in I got a value. Yeah? Okay, I'm actually going to stop here because my iPad is definitely going to die and I don't want it to die in the middle of a question. So I'll pick back up in a sec.